Hey, pause it for these 6.6 notes. Big idea. Okay, so you've seen what we have to do. We're just going to go through some examples executing it. So step number one is to isolate the radical, and you'll see what I mean by that, if possible, in a second. But this one we can. We can isolate. We'll subtract 1 from both sides, so we have the cube root of x minus 5 is equal to negative 2. Just remember that you could rewrite this as x minus 5 to the 1/3 is equal to negative 2. Regardless, you are going to raise each side to an appropriate power. Well, this power is going to be taken care of with a cube. So we will have a x minus 5 left over is equal to negative 2 to the third is negative 8. Add 5 to both sides, and x equals negative 3. We want to check our answer here. We'll talk more about why it's going to be important in a little bit, because you may have an extraneous solution, but I want to check. So it's negative 3. I'm going to plug it back in and make sure I get an equal sign. So negative 3 minus 5, it's the cube root of negative 8. If I add 1 to that, do I get negative 1? Well, this is negative 2 plus 1, negative 1 equals negative 1. Negative 3 is a solution. All right, let's do it again. Isolate, done. The square root is by itself. Raise each side to the appropriate power. When I say side, I mean the entire side. You don't get to pick and choose what you want to square. So this becomes x minus 2 times x minus 2. Over on this side, the squares and the square root cancel, leaving us with just x plus 10. So we're going to multiply this out. First, x squared. Outside would be negative 2x. Inside would be negative 2x, so that makes a negative 4x. Last is 4. This is equal to x plus 10 on the side. Subtract x. Subtract 10. And we have a quadratic. We have to solve the remaining equation accordingly. This is a quadratic, asks us to get this equal to 0. And you've got a couple of methods for solving a quadratic. You can use the quadratic formula. Factoring, I think, would be the easiest method here. What multiplies to negative 6 adds to negative 5. It's got to be negative 6, positive 1. So it's x minus 6, x plus 1 equals 0. So the solutions include x equals 6 and x equals negative 1. And this is where we have to be very careful with our solutions. I'm going to go back to the original, and I'm going to plug those things in. First, I'll check 6. So go back here. 6 minus 2 would be 4 on that side. Over here, we would have 6 plus 10 is 16, and 4 equals 4. Put a box around it. That is a solution. Check negative 1. Negative 1 minus 2 would be negative 3. Does that equal negative 1 inside of the square root? Negative 1 plus 10 is positive 9. The square root of 9 is 3. This does not create an equal sign. X equals negative 1 is extraneous. Okay, it is a apparent solution that you must reject. And I'll give you a brief explanation of why. Right in this first line, you can see why that solution came. When we square it, if you were to square both sides, negative 3 squared gives you 9, positive 3 squared gives you 9, and it would be true. So at this line, this is a true statement. But back to the original, it does not work, so we must exclude it. Only 6 is a solution. Rational exponents. How do we deal with rational exponents? How do we deal with fractions? We deal with it the same way we do when it's multiplied. We're going to take the reciprocal. But we're going to do the reciprocal in the exponent. When you take 3 over 2, multiply it by 2 over 3, you get 1. So you've got 3x plus 4 is equal to 16 to the 3 over 2. Now, one thing that we need to be careful about here is, do we need to include positives and negatives? If you look at this, that 2 means that it is squared. This really means 3x plus 4 squared, and then it's the cube root of that. Anytime you have something to an even power, it changes sign. So when you take and evaluate 16 to the 3 halves, which is going to be the square root of 16 and then to the third, so it's 64, we need to consider positive 64 and negative 64. Well, at least consider it. In fact, it really doesn't hurt to consider it all the time. We can check our answer in the end to see if it actually worked. But you especially need to be careful when you had something originally squared. So if we take the positive version, 3x plus 4 is equal to 64. You're going to subtract 4 from both sides. That gives you 60. Divide by 3, x equals 20. And we'll check that. If we take the negative version, 3x plus 4 equals negative 64. Subtract 4, you get 68. Negative 68. Divide by 3, x equals negative 68 over 3. So we're going to have to check both of these solutions. And so I will go back and look at my original, and I will plug in 20. So it's 3 times 20 plus 4, all to the 2/3. Does that equal 16? So it's 64 to the 2/3. Check it on your calculator. 64 to the 2 divided by 3 is 16. 16 equals 16. I'll put a box around it. I know my answer is complete. I'm also going to check negative 68 over 3. So I have 3 times 68 over 3 plus 4, all to the 2/3. Does it equal 16? So this 3's will cancel out. It's negative 68, excuse me. So it's negative 68 plus 4. It's negative 64 to the 2/3. We have to check if that is in fact going to be 16. So we got parentheses, negative 64, close your parenthesis, to the 2/3. In fact, you do get 16. Both of these are solutions. Okay, last one here. This is by far the most difficult. You are going to have to square both sides and expand this even though it's a square root. You can't combine them, and they aren't going to go away. You don't get to pick and choose what you square, so you are going to have the square root of x plus 6 plus 2 times the square root of x plus 6 plus 2 is equal to, the square root does cancel over here, it's 10 minus 3x. Alright, so what happens in this one? Well, we multiply this. The square root of x plus 6 times the square root of x plus 6 is just going to be x plus 6. Outside will be 2 times that square root. Inside will also be 2 times that square root, so you will have a total of 4 times the square root of x plus 6. And then finally, 2 times 2 is, plus 4. Over on this side, still 10 minus 3x. So now solve appropriately. Well, we have another square root function. So what do we need to do? Isolate the root. This is a total of 10, so I'll subtract 10 from both sides. That's nice that they cancel out right there. Subtract x, and I'm left with 4 times the square root of x plus 6 equals negative 4x. Now you have an option here to cancel the 4's. If you choose not to divide by 4, when you square, remember, the square needs to go here and to here. Likewise on this side, the negative 4 needs to be squared and that. Because we have a 4 on both sides, I am going to divide both sides by 4. And I would recommend isolating as far as you can so you avoid that problem. So this leaves us with a square root of x plus 6 on this side and just a negative x on that side. Now we'll put my parentheses around, square it. This just turns into x plus 6 equals. This negative x all squared turns into x squared. Or negative x times negative x is just x squared. Subtract x, subtract 6. This is now a quadratic. 0 equals x squared minus x minus 6. Factor this to x minus 3, x plus 2. And I need to check my solutions, positive 3 and negative 2. So I'll go back up to the top. Does positive 3 work? So if I plug in a positive 3 here, I would get the square root of 9 plus 2. Does that equal, over on this side, 10 minus 9 is, or I guess this is a 3 right here, so 9. So 10 minus 9 is the square root of 1. Does the square root of 9 plus 2 equal the square root of 1? Well, 3 plus 2? No, it doesn't. Okay, so 3 is an extraneous solution. Check negative 2. They could both be extraneous for all we know. Clear out my positive 3. Let's check negative 2. Put in a negative 2 here. We get 6 minus 2 is the square root of 4 plus 2. Does that equal, on this side, if we put a negative 2 in, 3 times negative 2 is 6, so 10 plus 6 is square root of 16. This is 2 plus 2 equals 4. Our only solution here is x equals negative 2.